Yes, so this is for the 7-day revision group. So I'm going to explain a linear function, hyperbola, and okay, I'm going to do those two first so that we can answer the questions that we did yesterday. So a linear function, everybody knows that's a straight line graph. So we have something like this: y is equal to mx plus c, where m obviously is the gradient and c is the constant, which is the y-intercept. So m is also another formula, which is m is equal to y2 minus y1 over x2 minus x1. So this is for the gradient, and a straight line is something like this, right? So yeah, a straight line is something like that, and if it's increasing like this, we know that the gradient m is positive, and if it's on the other direction, the gradient is negative. There's really not much to discuss here. So let's say they give us something like this. They tell us that this is 2, here the intercept is 2, so we already know, and they ask us to find the equation, and let's say maybe they give us another point, which is 3 is to 4. So they give us another point, and they give us the intercept, and they tell us you'll find the equation of this graph or this function. So we write the general equation, which is y is equal to mx plus c. We need the gradient m, and we need the c. We already have the c. The c is this intercept. The c is always the y-intercept, not the x-intercept, the y-intercept. So it's y is equal to mx plus 2. Okay, sorry. And then to find the gradient, you can use this formula, right? We have y2 minus y1 and x2 minus x1. So we need 2 points. So we already have 3 is to 4, and then we gave us the intercept. The y is 2 at the intercept. Since it's the y-intercept, we know that x is 0, it's 2. So this is our x2, it's going to be 3. Our x1 is 0 minus 0 over our x2. No, our, oh, sorry, we need to say y, which is 4. y2 minus y1, 4 minus 2. Sorry, this is 4 minus 2. Then x2, which is 3, minus x1, which is 0. So this is 4 minus 2, there is 2, and then over 3 minus 0 is 3. So our gradient is 2 over 3, and obviously, as expected, it is positive because this line is slanted to the right. So we're going to have something like y is equal to 2 over 3 x plus 2, and that's our equation. And that's about it. The only other questions you're going to find here, it's like when maybe there are two graphs crossing each other, and then you need to find the equation of the other graph. So that's where you use the gradient. Say at that particular point they have a similar gradient. They will also ask you to find the equation y is mx plus c, but instead of giving you like something like this, they will give you a point, maybe 2 points, and then they don't give you the y-intercept, and then you are required to find the gradient and the y-intercept. So first, if they give you 2 points, you use this equation obviously to find the gradient, and then to find c, let's say you already have your gradient, which is 2 over 3. So y is equal to 2 over 3, 2 over 3 plus 2 over 3x plus c. So to find c, what you're gonna do, you're always gonna substitute one of the points. So we have 2 points here, which is 3 is to 4 and 0 is to 2. Or actually, let's say we don't know this one because that's what c is, right? Let's say they give us this point and another point, so we're going to substitute one of those points. This is x, this is y, and we have x and y here. So y is 4 is equal to 2 over 3, and then this x, we substitute 3, which is x plus c, and then we go ahead and solve, and then we find what our c is. So it's like the easiest function you'll ever come across. So that's why I'm like super fast explaining this thing, so that I can move on to the hyperbola. But if anyone doesn't understand, there's something that you don't understand about the linear function, feel free to ask. If there's a question that is showing you, please do ask on the group. So let's go to the hyperbola. So now, yes, I am gonna be a bit slower on this one because I mean the straight line is easy, so that's why I had to be fast. It's in the general formula for hyperbola is y is equal to a over x minus p plus q. So if you see something like this, which is a number over x and then plus another number, that's a hyperbola. The graph is gonna be a hyperbola. So this is a very fun function to work with. I think it's one of the best functions out there. So our a is just a constant, it's a number, and then x, obviously it's x and y, and then p is our asymptote, and q is also our asymptote. And then obviously the asymptote is where the graph is bent. You don't see the graph at that particular point or line. So most of the times asymptotes are lines. graph will never ever cross that point called the asymptote. It will always keep on approaching that point, but it will never cross it. So you're gonna see how that works in a moment. And another thing, it's a is important too. Everything here is important. If a is greater than 0, we have our graph like this. So mind you, what I'm drawing here is not the x and the y axis, it's the asymptotes. So when it comes to hyperbola, nobody cares about the x and the y axis. We care about the asymptotes. So every time we work with the hyperbola, you need to be concerned about these guys, not the x's. That's one thing that you need to be concerned about every time. When they ask you to draw your graph, this is what you should be concerned about first before you can worry about the x's and anything like that. I told you P and Q are the asymptotes. So this is P and this is Q. Q is the horizontal asymptote, so it's in terms of y, and then P is the vertical asymptote, so it's in terms of x. So some people get confused, like, wait, hold on, if it's vertical, why is it in terms of x, blah blah blah. So let me explain that real quick. P is just a straight line vertically. So if x is 3 here, if you go here, x is still 3. If you go here, x is still 3, still 3. So that's why it has to be vertical, but it operates in terms of x. That's what I should be saying. So if you move it here, say x is 5 now here, x is going to be 5 throughout the entire line. So that's why it's vertical, but it operates in terms of x. Same thing goes for Q. Q here, let's say y is 2 here, y is 2 throughout this entire line. X changes though. If you go here, you might find that x is -1. If you go here, Q is still the same, y is still the same. Say y is 2, but x has changed, y is still the same. So that's why it's horizontal but operates in terms of y. So Q operates in terms of this is G. Q operates in terms of y, and then P operates in terms of x. So we might as well just do this. P is to Q, and this thing P is to Q. This thing is important. Keep it in mind. P is to Q, because you know it's x is to y. So we must keep this thing in mind. It's gonna help us later when we're doing the axis of symmetry. So those are our asymptotes. And another thing, we have x minus p. We are always gonna have x minus p on our formula. Always gonna be x minus p. So when you see something like this, say it's a over x plus a number plus 4, that's no longer our formula. Our formula says x minus something. So if it's plus now, you should know that, okay, something has happened. Probably something like this. It was x minus 4. So then it has become plus. So every time you get something here, you should always, when they ask you to find p, it should have the opposite sign. So here, let's say this is minus p, but when they ask us to find p, we're gonna take positive p. If you have positive 4, they ask us what is p. P should have the opposite sign, which is -4. If it's -4, what is p? P is gonna be positive 4. If we have -4 here, p is gonna be positive. So every time we are asked to find p, we always change the sign from what we are given on the denominator. But Q, we take it as it is. So I hope you understand that thing. Let's say we have something like 1 over x minus 2. Then they ask you, what is the vertical asymptote? Vertical asymptote is p. So p is gonna be positive 2, because this negative belongs to the equation. This is p. P is positive 2. But if it's something like this, 1 over x plus 2. So I already know now, okay, no, p is -2. We take the opposite of this, because this means that it was something like this. So x minus, as per the formula says, always gotta be minus, then it was -2, which was our p. Then this minus multiplied into this one and became positive. So we always take the opposite sign, but not for Q, only for P. Since I've explained this, I'm gonna go back to this thing. A is greater than 0. This is A. So here we see A is positive, it's greater than 0. So if A is greater than 0, B's are my asymptotes. This is P, no, this is Q, and this is P. Our graph is gonna be on the first and the third quadrant of our asymptotes, not the x-axis. And if A is less than 0, obviously the graph is going to be on the second and fourth asymptotes. And you can see these are the asymptotes. This graph starts from the negative axis, goes towards 0, goes towards 0. Or actually, this is not 0, this is P. It goes towards P, goes towards P, goes towards P, and then starts going up. Continues to approach P, but never crosses P. And then continues on this side, but it's not connected. starts from here and then keeps going, but it never crosses P, which is the asymptote. Same thing goes for Q. It starts from the negative Y up until this Q right here, and then continues after Q going up. So it will never touch P and Q. So one thing you must keep in mind, whenever A is positive, your graph is going to be on the first and third quadrant, and whenever A is negative, it's second and fourth. So you must always know this from your head, not your heart. You don't think with your heart. So this is always going to be important when you're plotting your graph. It'll ask you to plot your graph. You're not going to find this on your formula sheets. You're not going to find any of this on your formula sheets except for this thing. And then you need to be able to extract your P and Q asymptotes. And then P needs to be the opposite sign. There's one more thing you need to know. There's something called, no, hold on, let's do this first. Before we get to that, there's the x-intercept and the y-intercept. So this thing is easy. No one cares about this, but they always ask you the x-intercept and the y-intercept. And the reason for that is to give you free marks. So x-intercept, we let y equal to 0. So whenever we have the x-intercept, we'll just say 0 is equal to a over x minus p plus q, and then we solve for x. And then on the other side, we let x equal to 0 when we want to find the y-intercept. So it's going to be y is equal to a over 0 minus p plus q, and then we solve for y. So that thing is easy. No one cares about this. You should know how to do this. And then we have x's of symmetry. So I sent a question about this yesterday, so that's why I wanted to touch on it. Axis of symmetry is something like this. Let me take a different color here. The axis of symmetry is a line in which you can flip or fold or whatever, I don't know, your graph in such a way that when you do that, it will still lie on the same points or the same coordinates. So let's draw another graph. Say these are your asymptotes, not the x-axis or the y-axis. No one cares about that thing. So let's say this is our graph. So they are saying the axis of symmetry is a line in which if you fold this graph will just line up exactly with this one. It will lie on top of this graph. So obviously it's going to be a line that goes like this through this point where the asymptotes meet. So whenever you do that, you draw this line or on a hyperbola, the graph is always going to lie on they're always going to lie on the same coordinates if you fold that graph. Or if you do it this way, if you fold it about this line is going to lie exactly on top of this one, and this one is going to lie exactly on top of this one. So it's symmetrical about these two lines. And then what do we call these lines? This line is called y is equal to x, and this one is called y is equal to, no, actually this one is equal to y is equal to x. This one is the one with the negative gradient, so it's y is equal to minus x. So simple as that. Those are the two lines in which we can flip our graphs in such a way that it still coincides with the previous graph. So that's why we saw that question yesterday. The first question has something to do with this. So they're gonna ask you, find the axis of symmetry for this graph. And if it's a hyperbola, this is what you do. Every time they say find the axis of symmetry, your axis of symmetry is gonna be one of these two lines or both of them if they say find both. So what you do is it's y is equal to x plus a constant 1, which is c1, or y is equal to minus x plus another constant, which is c2. So these are the only formulas which you need. I don't know if you want to find this. I don't think you want to find this on your formula sheet. So you need to know this by your head, not your heart. Okay, every time they ask about the axis of symmetry, or they tell you something about, if you fold the graph or if you flip it and then it still coincides something, that's the axis of symmetry. They're basically trying to ask you about the axis of symmetry. So you need to bring in mind, okay, y is equal to x plus c1, which is a constant in c1, or y is equal to minus x plus c2. Both of those lines are our axis of symmetry. But this is not a full equation or a full formula because it has a constant which is unknown. The only thing that needs to be unknown is x and y because they represent any point in the graph. So we need to find these constants. So if they ask you to find the axis of symmetry, you're gonna have to write this and solve for the constants, right? Okay, so how do we solve for these things, these constants? Very, very important. We go back to this thing that I wrote earlier. P is to Q. That's a point. This point is where our asymptotes cross. So this asymptote is at x is equal to 2 and this one is at y is equal to 2 also. So this point where they meet, obviously is going to be P is to Q, which is going to be 2 is to 2. So that point is the only point we substitute in terms of x and y. You don't substitute any point on the graph when we are looking for the axis of symmetry. We only substitute the point where the two asymptotes meet. So they might not tell you that, oh, this is where the asymptotes meet, but they might tell you, okay, the asymptote is 2 and the other one is 2. So you already know, okay, they're gonna meet at 2 is to 2. So you just need to write your point like this: P is to Q, and then you substitute that point in terms of x and y. So obviously P is x and then Q is y. It's every time they ask you something that has to do with the axis of symmetry, you first write down these two formulas for a hyperbola. Y is equal to x plus c1, or y is equal to minus x plus c2, and then you write your point P is to Q, which is in terms of x is to y, and then you write your asymptotes, right? P and Q. That's the only thing you're gonna need to solve these questions. And then you're gonna go ahead and substitute Q in terms of y is equal to P plus C. So these are gonna be numbers, right? And then you're gonna be able to solve for C. C is gonna be something, and then you write your equation in terms of y is equal to plus that C. So let's say our asymptotes were P. Let's say P was 3, and then the other one was 4, which is Q. So P is to Q, 3 is to 4. Let's just say they told us P is 3 and then Q is equal to 4. So they tell us you'll find the axis of symmetry for this thing. So what you do, obviously I'm gonna do, let's just do this one. You're gonna say y is equal to minus x plus c2. So you substitute your y is obviously Q, 4 is equal to minus your x, it's 3, minus 3 plus c2. And then we need to transpose that thing. It's going to be 4 plus 3 is equal to c2. So c2 is equal to 7. Therefore, y is equal to minus x plus 7 is your axis of symmetry. Same thing goes for the one with the positive gradient. And that's basically it. And that's why I wanted to write it on one piece of paper to show you how easy it is when it comes to hyperbola. That is everything that you're gonna need. Or actually, there are most important things that you're gonna need when it comes to the hyperbolic graphs. So it turns out there was something left. It was this is a D, domain and range. A domain is where the graph exists in the x values. So we have something like this. Okay, let's say these are the asymptotes still. So your graph is like this. So when they ask about the domain, you only look at the x values, not I don't want to say the x axis. So you look at the x values starting from the negative x's, right? Start looking at the negative x values. So this graph goes all the way to infinity. So it starts at infinity, comes towards the asymptote, and then just stops. So actually it doesn't stop, keeps approaching the asymptotes but never touches, and then ahead of the asymptote continues all the way. So what that means is that the x values is an element of real numbers. It holds for all numbers on the graph except when x is equal to p, because this is p, right? So it's x is an element of real numbers except when x is equal to p. So x cannot be equal to p. So that's how you write a domain for a thingy, a hyperbola. So p is obviously going to be a number, right? Let's say maybe 2x. You can say x is not equal to 2. X is an element of real numbers where x is not equal to 2. And the range, same thing, starts from the negative y values, because the range is just the exact same thing as what a domain is, but for the y values. So look at the y values, start from negative infinity, stops here before the domain, then no, stops here before the asymptote, and then after the asymptote continues, and this asymptote is q, right? So we say y is an element of real numbers, because now it's a range, you're looking at the y values. It holds for all y values except for this one y value, which is q. So but y cannot be equal to q. So and we are done. That's our range and our domain for a hyperbola. Never changes, same thing every time. But now I'm gonna go and do those questions that we did yesterday, and